In this activity, we're going to put together a two-way table based on results that we get when we open up these different bags of M&Ms. So I have a birthday cake type of M&M and the plain old peanut and milk chocolate M&Ms. So we're going to open these bags and put them into a two-way table.
Okay, my first step is to gather the data. So I'm going to go ahead and look at this one first, and then you'll see how we do it, and from there you'll see the pattern that we use. Okay, so we split this up into our different colors. Looks like we got a lot of yellow, so I don't know, do we count that one? I think we just throw it up. Alright, so it looks like we have 5 red, 5 blue, and 6, 7, 8, 10, 11, 12. 12 yellow. Okay, and we're going to do that for all of the different types. Okay, now I'm ready to build my chart, now that I've collected my data. And in this chart, I'm going to have 3 different categories. So this was, we call it as birthday cake. Birthday cake. And then the next type of bag that we had was peanut. And then we had milk chocolate, plain M&Ms. Okay, and then we had various colors, right, that go with each one. So there was red, yellow, blue, brown, green, orange, and am I missing any? That's it. Okay, so now we're going to fill in the data, and now this data, so how many reds were there in the birthday cake pack? So this is called joint data, and it makes like a joint, like your elbow, right? You make a little L shape, and this is the joint frequency right here. So how many times did that happen? And let's go back to my list. Okay, birthday cake had 5 red, and it had 12 yellow, and it had 5 blue. And then, as you notice, there weren't any brown or green or orange, so we'll put 0. I don't think that birthday cake has those colors, but it might have been the case that they did. I don't know. Getting 0 would be kind of maybe a fluke if it does have brown, green, and orange. Peanut M&Ms. So peanut M&Ms, I put down, let's see, red, 4, yellow, 10, blue, 4, brown, 6, green, 5, and orange, 10. And finally, milk chocolate, which is probably the most M&Ms in that case. So this had 10 red, 15 yellow, 27 blue, 15 brown. Too much. Okay, so those are all the joint frequencies in those two packs. Now what we're going to do is called marginal frequencies. So how many, and this is in the margin, you know, if you remember using Microsoft Word or something, the edges are called the margins. So we're going to total these up. So this is going to equal the sum of, and then put parentheses and say all of these numbers. So the sum from B2 to B4. And so there's 19 red total. And I'm just going to copy this formula over. So I hover over the corner and drag it. And this will do the sum of everything that's above it. Okay, C2 to C4 and G2 to G4. All right, and then I also want to total in this direction. So this is also a marginal frequency, and I'll find out how many different M&Ms were there in the birthday cake pack, right? So I say equals sum, and close or open parentheses, and I drag across, and close parentheses, and it says 22. So there's 22 M&Ms in the birthday cake pack, and I can copy that on down, and I can see that the total for each bag, and you see that there is a lot more plain M&Ms than there are the other two. And that kind of makes sense because they're smaller, right? Okay, finally I'm going to make two more tables. These two tables will represent the conditional frequency, and that tells us the percentage of each type that we have. And first I need to find out what is the total number of M&Ms in all the packs. So that would be equal to the sum of all of these numbers right here. 164, and it should be the same number as the sum this way. So let me just check that. I'll say equals sum of all these. So adding up all the different colors should be the same as adding up, and it is adding up all of the different packs. So 164 is the total number of M&Ms. And now what I'm going to do is find out what is the relative frequency of the birthday cake pack. So this should, well, first, relative frequency of birthday cake would be how many reds were there in the total pack. So it should add to a total of 1. And the way to do that is I say equals 5. So there's 5 M&Ms divided by the total number in that pack. So there's 22. Okay, and the next one, yellow. And actually I could just copy this formula over, I believe. Let's see. Except what I want to do is I wanted to copy the 5 and the 12 and the 5, but I want it to keep dividing by the same number, 22. So the way I make it stay the same when I drag it is to put dollar signs next to it. So I put $H, $2, and then it won't move over. So now I just drag this over, and let's just check to make sure I did the right thing. Yeah, it said D2, which is a 5, divided by H2, which it stayed as 22. And you can see that it will always stay as H2 when you put the dollar signs next to it. Okay, and this, I think I can just copy this down, right? Because this will still divide by, oh, it'll divide by H2, but I don't want it to divide by H2. I want it to divide by 39, which is H3. And I think I can just take the dollar sign off, and then, oops, take the dollar sign off, and then when I drag it again, it will change to 4, but it stays H. So now enter, and now I'm going to drag both of these columns over, and it should match up. So this is H4. So this stays as H4. And this one stays as H3. And now this total, so add all of the relative frequencies together should sum up to a total of 100%. So this should be equal to, if I sum them, sum of all of these cells equals 1, which is 100%. And if I copy that down, they're all 100%. Okay, and then if I sum these this way, it'll tell me the relative frequency of the total number of red M&Ms, right? This is equal to just sum of these three. So 0.43. Actually, this is not the percentage, is it? No, definitely not. So actually what I want to do is take this number divided by the total number of M&Ms. That's what I want to do. So I say equal, just like I did above. Actually, I could just copy this one down. Right? Yeah. And it's H5, just what I wanted. So H5, which is 164. Yeah. All right, so that's a way that you find the relative frequency of the different types. So if I want to look at this chart and find out how many blue peanut M&Ms were there in the peanut M&M bag, well, there's 0.1 or 10%. And if I want to find out overall how many blue M&Ms were there, and it was actually 22% of all the M&Ms were blue, or I can say 17% of all the M&Ms were orange. So that's sort of interesting because in the top bag there was only 3 colors, right? And then turns out that red of the total was only 12%, but it looks like there was enough orange peanut M&Ms and milk chocolate to make up the difference, so that there's more total orange M&Ms than there are total red M&Ms, and you see that right there. There was 28 versus 19. Okay, one other way that we can organize these is to say what is the percentage of red M&Ms that were in the birthday cake pack, or the peanut M&M pack, or in the milk chocolate pack. So the way that we do that is we would say, well, this is equal to 5, right, divided by the total number of M&Ms that were red. So that's going to be 19. And this is the kind of thing that I want to not change the 5, right, because when I drag it down, I want it to stay as 5. So I'm going to put $sign on the 5 and drag it on down, and this should total up to 100%. Sum of these numbers, enter, and it does. And now I can drag that number across and like that. And actually I can drag these numbers down. I don't want these ones here. I want to prove that I did it correctly, so I'll say equals sum. Actually I can drag this equation across. This is sum, right? So I sum those 3 up, and then if I drag this across, it will sum these 3 up. Yep. Alright, so it makes sense that 0% of the brown M&Ms came from the birthday cake pack, right? And 71% came from the milk chocolate. And it does seem that the milk chocolate is going to pretty much dominate this list because there are just more of them. Does that make sense? Alright, so that's how you put together a two-way table and organize the data given joint frequencies, marginal frequencies, and conditional frequencies. So conditional frequencies are the percentages. And one last thing, you can show that the total number of M&Ms or total percentage that came from birthday cake was 13%, 24% for peanut, and 63% for milk chocolate. And that way that you do that is just same as these. You take this number divided by that number. So this is 22 M&Ms out of the 164 that were of the total, just like we took 5 out of the 19. So 5 out of the 19 was 26%, and 22 out of the 164 is 13%.